Oh, oh, oh. We are talking about the abacus. Why do we talk about the abacus? Excuse me. Oh, a little tired. Mm-hmm. We are looking here. So then we need to do is we need to read the abacus. Abacus. Go, go. I have this one and I have. There we go. There we go. Hello, hello. My name is Lynette. What are we doing? We're reading the abacus. This is an abacus. And what are we doing? We're going to count. 1, 2, 3, 4. That is the value of 4. Anytime that the beads are touching this horizontal bar, this is considered counted. So if you notice, none of these columns, these are columns, these are being counted. This one's being counted. None of these are being counted. So that means what? This is 4. Easy. This is 5. This will always be 5, no matter what. So this is 5, 5, 5, 5, 5. These are all 5s. Now if we look, I'm going to clear it. That's what clear is. When we add 1, 2, 3, 4, and then we have 5. Notice when I do 1 and I add the 5, now we have 6. If I have 2, when I have 2 and I add the 5, like that, there we go, 7. That's 7. And then we have, what do we have? We have 3, 1, 2, 3, and then we have 5, and this is 8. 8. 5, 6, 7, 8. Let's see, can I make that better? There we go. So when we have 4, 1, 2, 3, 4, and then we add the 5, now we have 9. How are we doing? Anybody? How is everybody? Let me know. Let me know if you have any questions. So the first thing we're going to do is understand how to read the abacus. After we read the abacus, we're going to do some adding, subtracting, adding and subtracting. And I think that's as far as we'll go. So what we're going to do is we're going to count again. When we count again, it's going to be 5, 6, 7, 8, 9. That's how we do it. So then if we look, this is 0. When this is 0, that's 0, right? That means that none of the beads are touching the horizontal bar. That's 0. And then we have 1. So we go 1. And then we have 2. So 2 looks like this. And then 3. 3 looks like this. 1, 2, 3. And then 4. 4 looks like this. Oops, not 4. There's 4. This is 4. But then if we did this, these are all 4s, right? But then what happens? Then this means that we're going to do columns. So when we have this number, this is 40. So this number was 40. Now, why is this 40? This is 40 because I have my tens. So if I match it up, I have my ones, my tens, my hundreds, my thousands, my 10,000. And that's what I'm going to do when I match it up. When I match it up, and then if you notice, I have this dot indicator. This dot indicator tells me where my ones is. You could choose this one, or you could choose this one. It doesn't really matter. It's like a Pokemon. You get to choose whichever one you want. If I chose this one, then that means that when I go here, I don't have any more hundreds. So I have to kind of be understanding how many digits I have. So when we look, we're going to count again. We have 1, 2, 3, 4, and then we have 5. This is a value of 5, and then we have 6. How do I know? Because we count, and we can count on. We have 5, we have 6. These are touching the horizontal bar. So because they're touching the horizontal bar, these are, what do you call it? These are being counted. Yep, yeah. So because they're being counted, then we have 7, 5, 6, 7. And then after 7, we have 8. 5, 6, 7, 8. 5, 6, 7, 8. And then we have 9. 5, 6, 7, 8, 9. Now, if you notice, these are made out of plastic, right? And they're very easy to move. It's like a rattle. So let me know if you have any questions. What we're doing is we're just learning how to read the abacus. After we learn how to read the abacus, we will go into understanding how to add and subtract. So the first thing we're going to do is we're going to count 1, 2, 3, 4. That's 4. And then we have 5. That's not 5. This is not 5. This is 9. How do I know? Because it's 5, 6, 7, 8, 9. This, the top bead, will always be 5 no matter what. So this is 5, and then this is 6, this is 7, this is 8, this is 9. So what does that mean? So this is 5, and then we're going to count 6. 5, 6. 5 plus 1 is 6. And then we have 2. 5 plus 2 is 7. And then this is 8. 5 plus 3 is 8. And then we have 4. 5 plus 4, 9. 5 plus 4 is 9. Thank you. Thank you for the hearts. Thank you, thank you, thank you. Okay, so what are we doing? We are looking at how we read the abacus. When we read the abacus, we'll do 10. So after 9, right, if you notice this is 9, if I did all of this, these will all be 9s. And I can do that here too. So when we look, we have our ones, the decimal sits in between the tenths, and then we have the hundreds. Notice that when I do that, now we have 0. And then that's what these are. This is the reference sheet. This reference sheet tells me what number this is. So if I look at this, it says, when 3 bottom beads touch the beam, these beads are counted. This abacus displays 3. So when I do that, the abacus displays 3. Anybody have any questions, let me know, and I will answer them. Anything about abacus, all things abacus. We can do anything about abacus. And so here we have 4. This is the value of 4. No, not the value of 4. This is 4. This is 4 items. 1, 2, 3, 4. And when we look, I want to do 5. When I do 5, it looks like that. So how does that look? Does that make sense? Let me know if you have any questions. For those people that are coming in, thank you for joining me. My name is Lynette. I am an abacus teacher, and I enjoy teaching everybody how to read the abacus. I do have this in my TikTok shop if you're looking for a 7-column abacus. When I zero it out, I'm going to zero it out, and then we're going to be looking at this is 0. So, but how do we do 5? Well, 5 will always be the top bead. A 5 is the top bead. And then when we do 6, you'll notice that when the top bead touches the beam, this is the beam, and the one bottom bead touches the beam like this, now we have the beads that are counted. These beads are counted, and this is the value of 6. How do we know? Because they're touching the horizontal bar. This is the horizontal bar that we use to track our numbers. So when we look, we have 6. And then when we do this, this is 0. These are all not touching the horizontal bar. So this whole abacus is uh, 0. So we have 2, and then we have 5, and then together we make 7. And then we have 3, 1, 2, 3. We add the 5 because the top bead will always be 5, and we add that down. Now we have 8. Whew. So we have 8, and then we have 4. 1, 2, 3, 4. Because we have 4 and we add the 5, now we have 9. Yeah. So then we're like thinking, well, what happens after 9? Well, we have 10. Well, what does 10 look like? 10 looks, we know what 10 looks like, right? 10 looks like this. 0 and 1. 0, 1, 1, 0. So when we look, we just copy it. 1 and 0. Thank you for joining. Thank you for the follow. So what we're going to do is 1, 0. Well, after that, we do 11. So we have 1 and 1. Thank you for the hearts. Oh, thank you for the heart me. The Adam King. Yes. So when we look, we have 12. 1, 2. Oh, 2. So that's what 12 looks like. And then we can continue on, right? 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Anybody have any questions? Let me know. So that's it. That's it. We're done. No, we're not done. We can do some adding and subtracting. But the first thing we're going to do is we're going to understand how to read the abacus. So if I was to show you what this number is, let's see. If I had this number, what number do you think this is? Please put in the chat if you know what number it is. Hello. Thank you. Wow. The Adam King. I hope that's a good wow. I hope that's a good wow. I hope it's a good wow. I hope that that you're understanding and it's easy. Hello, Scarlett. Welcome back. Hello, hello, hello. Adam King just said wow. I'm not sure if Adam King is it a good wow or a bad wow? Is that 10? No, this is not 10. How do I know? Because if I look, whoa, sorry. If I look, here's my ones. There we go. So my ones, my tens, my hundreds. And when I see it, I have 3. 1, 2, 3. This is 5. Yes, Scarlett, it is. 200 because this is my hundreds. So 253. Exactly, exactly. Thank you, Scarlett. Does that make sense, Adam? Does that make sense? The king, Adam King. So when we look at it, every column. This is my first time here, but yes. Okay, no, not a problem. Let me know. Let me know because it feels lonely when nobody comments. You know what I mean? So please, I enjoy the comments and the questions. And so I'm happy that you're here joining me, Adam, because you're here. So when we're doing it, we want to read 1, 2, 3, 4. So when we have 4, oh, thank you so much, Scarlett. I'm so happy. So this is 4, and then this is going to be 5 because the top beat is a value of 5 no matter what. We have 5, we have 6. So when we have 6, we have 7, 8, 9. And then we have 10. we notice that 10 looks like that. Does that make sense, Adam? So when I show you here, right, we have 10. 10 looks like this. We have our 1 and our tens. So when we look, this is 1's 10. Now when I do 11, that's what 11 looks like. 1 and 1. What you gonna do? 1 and 1. I don't know if that's a baseball chant. Anyways, so now we have 12, and 12 just looks like that. So what it is abacus mimics the way we write. So when we look at it, we can do this. What number do we think this is? What number? Oh, thank you so much for the TikTok something. The gift. Thank you, Adam. Thank you so much. So what number do we think this is? If this, oh, I should bring that back. We should bring it back. Okay, so what we're going to do is we're going to understand that thank you so much for the hearts. So what we're going to do is understand that every column, these are columns, every column has a place value. So when we look, we have ones, tens, hundred, thousands, 10,000. So if I have this number, what number do we think this is? Yes, thank you. Thank you. Yes. And Scarlet. Yes, great. 900. How do I know? 5, 6, 7, 8, 9. This is 9, and it's in the hundreds column. So this is 912. 1 and 2. Great. Awesome. Makes sense? I'm so happy. Thank you. Thank you. Thank you. So what we're going to do is we're continuing to read the abacus, right? And when we do this, what number do we think that is? That's not tricky. That's easy. That's easy. Thank you. Hello, Alexis. I'm slowly understanding this. That's fantastic. I'm so happy. It takes a little bit of time. I'm not saying that you should know it like right away. If you knew it right away, then you didn't. Then you're not abacus, and then I wouldn't be around. oh, says 729. Yes, 700, 5, 6, 7. That's 700. This is 7. This is hundreds. This is 229. Indubitably. I like your words. Thank you. So we have 9, 5, 6, 7, 8, 9. 729. Exactly. Thank you, thank you, thank you. That makes a lot of sense. Let me know if you have any more questions. Let me know where you guys are all from. I am from California, Monterey Park. And what I do is I teach abacus, and I teach abacus to everybody actually. I can't wait to hear I can't wait till my baby is 3 so I can teach her this. Yeah, that's crazy. South Carolina. Oh, hey, Lee, whoa, you're here voluntarily to learn math in the middle of the night? Come on, Alexis, that's crazy. That's crazy. It's only 10:30 for me. Oh, Pennsylvania, you guys are like in the middle of the night. California. Whew. Pennsylvania, come on, you guys are Wisconsin. Wow, you guys are dedicated. Hello, Kat. Miami. Oh my god. So is it a good thing that we're doing midnight math? I've always wanted to know how to use one. Oh, interesting. Okay. So let's do a little review. So when we look, same. Oh, Adam King. You guys are so funny. But it's the middle of the night and you're learning math. What kind of math is this? This is counting. All we're doing is we're counting and we're learning how to count on the abacus. So we're going to do 0. This is 0. That means when all the beads are not touching this horizontal bar. This horizontal bar is, hey, I remember everything from yesterday, so it worked at night, I guess. An all-nighter math lesson. That's crazy. All right. So this is the horizontal bar. This horizontal bar is what counts our beads, right? So what we're going to do is we're going to count 1. All the lower beads has a value of 1. That's what this means. Anything lower on the lower bead, right? These are all the lower beads. If we're talking about the abacus world, we call them, what do you call them? We call them earth beads and heaven beads, if you want to be poetic. I was so excited to share with my family. Oh, that's so funny, Scarlett. That's so funny. So we have 1, this is 2, this is 3, this is 4. Easy, right? Simple to use, easy to understand. Now, if you notice, now how do we do 5? The top bead will always be 5, no matter what. The top bead will always be 5, no matter what. So when I do this, it looks very familiar, right? I saw this yesterday. Are you on the same math problem from yesterday? No, I'm counting. So what I always do is I always start off with counting. I love this. Thank you, Adam. So I always start off with counting because there's always going to be new people understanding how to count. I'm just being playful. Corgi, you're so silly. You know, there was another one. Enrique was like, I want to test you how fast you can. I want to test how fast you can do adding and subtracting. And somebody's like, what? And I'm like, there you go. Okay, sorry. You have to learn this. I'm not in school. Wait, I'm not in school, and this live before Gu Yu soon. Okay, have a good one. I'm not sure what that means. So when we do it, we have one, and now when we add the five, now we have six. Okay, how do I know? Because remember that the top bead, the blue bead, will always be a value of five. So when we add it, we have six. So we have two, and then we have five, now we have seven. We have three, and we have five, then we have eight, and we go for nine. I'm sorry, four, and we add the five, and then we have nine. That's it. We're done. No. So what now? What do? We do 10. How do we know that this is 10? Well, we know this is 10 because I have my place values. When we do 10, it's just like how we write it. It's just like how we write it. It's just how we write it. So we have our ones, our tens, our hundreds, our thousands, our 10,000. So just as we write 10, 0 and a 1, we have a 0 and a 1. All right. Bruh, I find do it with you. Nice. It can be really handy in life. Yes, exactly. I'm grown already. That's fine. You can move on. You don't need to stay here. You don't need to be voluntarily staying here. Do you think it might be helpful for me to label the beads one, two, three? No, no, I don't think so because it's going to be a crutch, right? So I honestly think that if you just kind of practice with it a little bit, it's like playing the piano. When you play the piano, do you put in the numbers of the keys? You know what I mean? Like C D E F G. You know what I mean? So I think it's like practicing the piano. You would get to a point where you get to a point where it kind of makes sense to you. For my baby, no, the baby won't. No, I wouldn't because when you get pens, let's say you get pens, you're not going to count one, two, three. You know what I mean? Muscle memory. It will be muscle memory later. Why do you have badges for this live? Because he's very generous. I don't know how to play the piano. Well, it's like tying your shoes, right? And it's like it's like tying your shoes, or when you ride a bike, you don't need to always say, okay, label that this is a pedal, this is the left pedal, this is the right pedal. You know what I mean? So free teaching. Yeah, this is free teaching. I'm trying to teach, but you guys are, yeah, I don't know. It's just I don't know how to say it in him. So she's just saying that you don't want to rely on labeling. Yeah, I think so. I mean, the reason, yeah. And that's like, I mean, labeling like cabinets because you want your child to learn how to read. That makes more sense. But like for this one, it's more like trying to just understand that these are because you know what? You know what, Scarlett? Because when we take away one, we don't want to say this is one, right? We if we label this one, but then we want to remove one, that's what it is. You know what? That's why I wouldn't label it because when we minus the one, we want to move the one beat. It can be any one. Yeah, it can be any one. That would be the reason why I wouldn't label it. Does that make sense? So when we look at it, right, when we want to take away two, right, how do we know we're taking away two? It's not going to be these two, it's going to be these two. So, yeah, that's why I wouldn't do it. So, what I would do is I would not label them. You will teach your child. That's great. Hey, oh, thank you, Maria. I know it. Yeah. I have three boys and they all know it. Oh, thank you, Adam, for the rose. Okay. So let's continue on. What we're going to do is we're going to continue to understand how to read the abacus. After we learn how to read the abacus, we're going to do some adding and subtracting. So the first thing we're going to do and to understand, so everybody in the chat, what number do we think this is? Best live on right now. Thank you, Adam. Yeah. Thank you. Okay. Okay, so what number do we think this is? I mean, I don't know the bickering, what's going on. Let's cool it because we don't need a bicker. It's where this is a safe area. We're just talking. And if you guys don't like it, you guys can move on. You don't need to, you are voluntarily being in my life. There is no point to be here in the middle of the night and start arguing with people. Alexis, thank you. 700. Yes, 700. Yes, 791. 1, 2, 9, 6. I'm sorry, 5, 6, 7, 8, 9, and then 1. And then, yes, 791. Good. Share with your friends. They don't know how to act. As long as you're your friends, I don't want to ban them. Oh, wait, I forgot that. Yeah, yeah. So that was the one thing is it's also making sure you understand the attention to detail. So my, my, I shake my head, guys. Yeah. Okay. So we understand how to read the abacus. We understand the abacus. We're going to start doing is we're going to understand how to move the abacus. Are we okay with that, or do we want to continue to learn how to read the abacus? How are we going to do? How are we feeling? We can do both. I have books on everything. I'm starting to make more books. I'm trying to make another book. I'm on my 10th book. It's fantastic. So well, I don't know. She's what? Multiplication. You want to do multiplication right now? Multiplication right now? How do we feel about multiplication right now? Or do you guys want to know how to add and subtract? How do we do? How do we feel it? How do we feeling? You want to do adding? Okay. Okay. We're gonna do adding for a little bit, and then Scarlett, depending on how we are, we're gonna go into multiplication. Is that all right? So what we're gonna do is the first thing we're gonna do is understand that in abacus world we will be focusing on the add-in. The reason why we're focusing on the add-in is because we want to know what the number is. When we understand how to move the number, when we understand how to move the number, then we'll understand why we're doing the things we're doing. So here, where the question is 5, I'm going to add 5. When I add the 1, I want to just move the 1 bead. Now, notice now I added the 1 bead, and this is 6. However, if I have 7 and I want to add the 1, see, Scarlett? Now I'm adding the 1. That's why labeling it wouldn't make sense. So what we're going to have is we have 8. So when we look at that, we have 0, and then we have 9. When we subtract, we're going to take away 1 bead. We only need to take away the 1 bead. Notice when we take away the 1 bead, it is a horizontal bar. We're going to move away from the horizontal bar. We're going to subtract. We're minusing. When we minus from the horizontal bar, now we have 8. When we minus the horizontal bar, this is minus 1. Now we have 7. Notice when we minus again, and then we have 6. So when we look, I'm going to do the next number, which is 2. When we have 2, I have 6. And then the question is do I have enough? Can we do it? Yes, we can. We can. So we're going to add 2 like that. When we have 4, like 2, and then can we add another 2? Yes, we can. We add 2. So my final answer is 4. And then we can add 5. Can we add 5? Yes, we can. And now we have 9. So again, we add the 3. Add the 3. Here's my question. We have the 5. And then when we add the 3, there we go. Can we do it? Yes, we can. We're going to add the 3. So my final answer is 8. And here we have 1. And then can we do it? Yes, we can. We can add 3. And so what we're doing is we're just adding the beads. We're adding the 3 beads. So if we add the 3 beads, we can subtract the 3 beads. If we add the 3 beads, we can subtract the 3 beads. When we add the 3 beads, we can subtract 4 beads. Notice how that works? So anytime we go away from the horizontal bar, this is what we call, hey, Ghost, welcome back. Minusing. So what we're doing is, and again, what we did is here, minus the 1. And notice the reason why I'm doing that is to show that what we're doing is we are moving the beads. So I have 3 over here. My question is 3, and then I take away the 1, and I want to minus the 1. Can you show us 4 plus 1? I can. Let me finish this one. Section, and then we'll go into the 4 plus 1, because understanding the fundamentals is crucial. So here is 3 when I want to have 8, right? I'm going to have 8, and I want to subtract the 3, and all I got to do is take away the 3. So what I'm trying to do is I'm trying to show what it's like when you have enough beads, you're going to take away the 3. When there's enough beads, you can do it, right? And again, if I have the minus 4, we do it again with the 5. Now, when we add the 5, all we're doing is add the 5. And then we have 1. My final answer is 6. If I have 4, and I add the 5, oh, you can't see that, and I have the 5, my answer is 9. So what we're looking for is how to remove the beads. But notice if I do this, don't flick too hard, because if you flick too hard, you'll notice that your beads will get messed up. So we're continuing on with how to add a 7. When we add the 7, it's bringing together like this. That's what adding the 7 means. So when we take it apart, we want to push it apart like that. So if I have 1 and I want to add 7, I'm going to bring the 7 together like this. If I want to take it apart, I do that. Oh, that's one more thing. So if you notice that the ridge of my beads, right? This is made out of plastic, and the ridge of my and there's the edge of my beads, and I'm using the edge of my beads to move. So when I do one, it'll be 1, 2, 3, 4. Notice I'm touching the edge of my beads. So it's easy to be able to move the beads. It doesn't matter how big your fingers are. This is a standard size. The way it looks, this is a standard size abacus. So it looks, the height is the same, the beads are kind of the same, and it's about the same. So just so you know, this is made out of plastic, and to also hold your abacus, because if you don't, your beads will get messed up. If your beads get messed up, then your answers get messed up, and that's a big suck. So, and it's very easy to move. So that's why you have to be careful. Thank you, Adam, for the roses. Thank you, thank you, thank you. So here is 8. When I add the 8, we have 1, and then we have 8. So then we have 9. Okay. What are we doing? Make sense? So we're doing it again, right? When we add, we know how to subtract, right? Here's minus the 7. So what we're going to do is we're going to add 5. We had 4, and then we want to take away the 7. When we take away the 7, I'm going to move the part like that. Ooh, that didn't make sense. So what I'm going to do is I'm going to make 7. I'll just move it apart like that. And that's how I make 7. Okay, so we're done. What happens? So Scarlett had a really good question. What happens when there's not enough beads? So that's when we start talking about what? We're starting talking about how to make a 5. Sorry, I have to think about it. We're teaching children how to make a 5. We're teaching children how to make a 5. Well, it's good because now we're getting to a point where we can actually, how it kind of coincides to math, like mainstream math. So there's this thing that we do is called how to make a 5. When we make a 5, why are we going to make a 5? Well, if you notice, I have my abacus and I have this 5. We're going to actually utilize this 5. What does that mean? Well, when I have my question, here's my question. Where's my question? Here it is. Here it is. I have my question. If I have 3, I'm going to put 3 on my abacus. When I put 3 on my abacus, I want to add the 4. When I add the 4, I can't do it anymore. Well, what do? I don't have enough beads to add the 4. I know that there's this concept. Plus 1 is equal to plus 4 plus 1 is equal to 5. That's the concept that we're going to do. But why does that matter to us? Well, what matters is we're going to actually utilize this 5. So when I look at my abacus formula and we utilize the 5, what we're going to do is we're going to take our number and we're going to isolate the variable. So my question is 4. This 4 and this 4 is going to be the same. What we need to do is we have this concept. Why? Because we're going to utilize this 5. What we're going to do is we're going to take this 1 and we'll move it over here. Why do we do that? Because we're going to isolate the variable. When we isolate the variable, we're going to have 4 is equal to 5. That doesn't balance, right? That's not balanced. What we need to do is we need to balance the equation. To balance the equation, we minus the 1. When we minus the 1, now we have directions. Oh, thank you for the hearts. Thank you so much for the hearts. So now, and thank you for the shares, Scarlett. So what's going to happen is I have directions on how to move the beads. So I'm just going to add the 5 and then take away the 1. All I got to do is add the 5, take away the 1, and my final answer is 7. So what did I just do? I didn't memorize. My answer is 7. I didn't memorize a strategy called doubles plus 1, doubles minus 1. I don't learn doubles. We don't memorize doubles. What we do is we memorize the formulas. We memorize this concept. This concept is a crucial concept, but it's versatile. So here's another one. Let's do another one. So here we say, is there enough? No, there isn't. Because what do we do when we're adding the 4? When we add another 4, there's not enough beads to add the 4. See how there's not enough beads to add another 4? So what are we going to do is we need to plus the 5, and then we're going to take away the 1. So my final answer is 8. Does that make sense? Thank you guys so much for the hearts and the heart me. Oh, and the rose and the TikTok something. Okay. Does that make sense? Yeah? Okay, good. Hey, Kat, you're back. So what we're going to do is we're going to understand, right? This is a very versatile equation formula. Well, in abacus world we call it a formula, but in mainstream I think they call it an equation. Yeah. Okay. So then what happens? Well, we could do it again, do it again, and show how versatile it is. The reason why it's easy to see is because the abacus, there's constrictions, there are restraints. Because there's constraints in the abacus, then we know that we can actually critically think what we're trying to do. So when we do it, we want to add the 2, and then we want to add the 4. When we add the 4, it's plus the 5 minus the 1. And my final answer is 6. So what we're doing is we're not memorizing our doubles. What we're memorizing is this formula. Now, this is a very critical formula to memorize, and it is now scalable. Does that make sense? So now we can actually scale, and it doesn't matter what number. As long as it's a 2, we can do it. But it will always be on the abacus. This doesn't just work for simple numbers like this. Now, knowing this concept, it actually goes into bigger numbers. Okay, so we did the 4. Well, guess what? We have others to work with. What? There's these ones that we can do as well. So we could do a 3, a 2, or a 1. So there's this one set. When we look at the one set, where's my. Oh, here it is. When we look at the one set, this is my set. If I want to add the 1, or add the 2, add the 3, or add the 4, let's do 3. We want to do 3. We want to do 3. So if I notice, my question is 3. So here I have 3. I'm going to learn doubles. No, there's no learning doubles. You memorize the doubles, but we don't memorize the doubles. Can you show me when you do a big number? Yeah, we can do a big number, but if I do it right now, it might confuse you because there's a couple more things that you need to see if that's okay, Bri Bri. Bri Bri? Does that make sense? So we can go into bigger numbers, but before we do that, I want to show you how it works. Okay? So because I could do this and then you won't know. Right? I could show you like the bigger numbers, but I would like you to understand the fundamentals before we go into all of that. But yeah, no, for sure. We will go into the bigger numbers and you'll see the beauty of the abacus, but we still need to lay the groundwork. And that's why I do is I try to understand and I try to show you the groundwork first before we go into the bigger numbers. Because after you understand how to add, subtract, then we can go into multiplication and division. Because then it'll be easier because we can rely on it. Okay, so again, when we do 3, we're not going to memorize the 3. Thank you so much for the hearts. So what we're going to do is we're going to add the 3. When we add the 3, we're not going to memorize. What we're going to do is we're going to utilize our formula. Remember, our formula is plus the 3 is equal to what? Plus the 3 is equal to minus the 5 plus the 5 minus the 2. So I'm going to plus the 5 and we're going to take away the 2. So my final answer is 6. So again, these are my formulas to add the 5. Plus the 5 is, we've seen this one, plus 5 minus 1, plus 5 minus 2. So notice that we have these pairs. So we have 2 and 3 is a pair, just like the reverse, right? And then 4 and 1 is a pair, just like the reverse. So it's the same thing here. 2 and 3 is the pair. So my answer here is 6. We can do it again. We have 4, and I want to add the 3. When I have the 3, I don't have enough beads to add 3. What do? I know I can plus the 5 and then take away the 2. So what am I doing here? I'm exchanging the 5. I want to add the 5 and I need to take away the 2. So my final answer is 7. Does that all make sense? I don't know if Adam's still around. I think he left. Scarlett, you around? You okay? Make sense? But yeah, Scarlett's been around though. And then Bri, does this make sense? And then Kat. And Alexis. Are we okay? Any questions? Any questions? Bueller? Bueller? Right. Okay, good. So now what we do is we know how to add. Well, now we have to subtract. Why are we going to subtract? Well, we're going to subtract because we have, what am I going to do? Oh, we'll do this one. We'll do it the back here. So when we do subtracting, getting the hang of it. Okay, good. Okay, good. Yeah. So the biggest thing is to understand, why we do certain things. So the next question is like 8 - 4. Well, we've seen -4, right? We have? No, we haven't. Well, we kind of did. If you notice, we have a 4. This one right here. 4 + 1 equals to 5. So what's going to happen is if I want to minus the 4, I'm going to take this information and I'm going to take away the 4. So I'm going to rearrange it. I'm going to copy the equation, but I'm going to make my signs opposites, if that makes sense. So right here, my question is minus the 4. 8 - 4. So here I'm going to isolate the variable and I'm going to move this to this side. So when I move the 1 to this side, it's going to be a plus. Minus the 4 is equal to minus the 5 plus the 1. What? Why are we going to do that? The reason why is because you'll see I don't have enough beats to take away the 4. I only have 3 beats to take away. I need to take away the 4. So what do? Is I have the 5 to exchange. I could do minus the 5 plus the 1. That's what I just did. Minus the 5 plus the 1. So what I just showed you is how to add the 4 and how to take away the 4. To add the 4, notice it's a number pattern. That's a pattern. You'll see. Add the 4, take away the 4. Add the 4, take away the 4. Does that make sense? So when we look, we know how to balance it out. We add the 4, we take away the 4. Right? It's the same thing with the 3. So if we have the 3, let's do 7. 7. So is it like regrouping? No, it's not like regrouping. It's like trading. It's like trading. So exchanging. So here I have my beats. So I have I have this, right? And I want to add um I want to add another 4. If I want to add another 4, what's going to happen? I only have a nickel. I only have 5 cents. I don't know where, well, for those people that are just coming in, a nickel is worth 5 cents. I only have 5 cents. So what I'm going to do is I'm going to give you my 5 cents, but that's too much. I need to exchange it to give it back to me, right? You need to give me back some money. So we do like a trade, if that makes sense. Does that make sense? So like we have 8, right? Oh no. I guess, yeah, we have 8. And then what do? Is I need to take away the 4. To take away the 4 is what? Minus the 5, and then I'm going to add the 1. So it's not regrouping, it's more like trading. Abacus, I think, is more trading than regrouping. Regrouping is using these and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think regrouping is a little bit different. I mean, technically it's different, if that makes sense. I don't know. I don't know. And then we take this and we make it a, I don't know, we make it a 10. I don't know. I don't use the word regrouping too much because in abacus world we don't call it regrouping. We just do a trade. We call it adding the 5 and taking away the 5. But yeah, I just got here. Can you show me an example on the abacus? Yeah. So this right here is 7. So when we look, this is 7. How do I know? Because I have 1, 2, 3, 4. When we add 4 to this horizontal bar, now it's being counted. Because it's being counted, we have 5. This is a value of 5. The top will always be 5. When we look at that, that is 5. All of this is 5. 5, 5, 5, 5, 5. Now, if I clear it, I'm going to clear it. When I do this, this is 1. But when I add the 5, now we have 6. When I have 2 and I add the 5, now we have 7. When I have 3 and I add the 5, now I have 8, right? 5, 6, 7, 8. When I have 4, 1, 2, 3, 4, and I add the 5, now I have 9. What type of math is this? This is arithmetic. So it's adding, subtracting, multiplication, and division. That's what we're doing. We don't do anything else. We don't do calculus. We don't do algebra. We don't do geometry. There's no trigonometry. There's no finite math. This is not finite math. This is the basics and the foundational pieces. So when you have a solid foundation of adding and subtracting, then you can go to higher math, more complex math. But the first thing to do is understand how to add and subtract, if that makes sense. So this specifically is about adding and subtracting, multiplication, and division. Those are the only things the abacus can do. You could do square root and cube root, but I don't know. I don't know it. Thank you for the follow. Thank you for the follow. So did that make sense? Luxuri? Lux. I will have to cut your name short and say Lux. Does that make sense? Wet soggy. Does that make sense how to read the abacus? So the first thing we're going to do is understand how to read the abacus. Now what we're going to do is we're going to add. When we add, we want to move to the horizontal bar. When we want to subtract, we want to move away from the horizontal bar. Okay, good. So what's going to happen is when I want to add 7, I'll add the 7. So when I minus the 6, I'm going to move it away like that. So notice, oh, have a good night, Scarlett. So when I move away from the 6, I'm minusing the 6, I move it away like that. So my final answer is 1. So what's going to happen is when we look at it, and if you're ever interested, I do sell this in the shop. The link is down below in the corner, and you could see it. And so this is made out of plastic, and it's very easy to move, so you have to stabilize it with your hand. The reason why you want to stabilize it with your hand, thank you, Scarlett. Thank you so much. I appreciate that. Um, you want to hold it, you want to hold the abacus with your hand, because if you don't, then your answer is going to get really messed up and you're going to really not like it because you will get the wrong answer, because it's very easy to move. Now the other thing is to move the beads. You'll notice that there's edges on the beads. What you're going to do is you're going to want to use the edge, the tippy tip of your finger, to move the bead like this, right? So we do 1, 2, 3, 4. This is 4. Oh no, there we go. 1, 2, 3, 4. Notice it's very gentle, right? It's not brutish. You don't need to do this and be all brutish, right? It's very gentle. And so it's about being delicate. It's not delicate, but it's not aggressive, if that makes sense. So when I move it, I'm usually using the tips, the edges of my thumb, just to move it. Thank you for teaching. I have to go sleep. Yeah, have a good night, Bri Bri. I know it's really late. Is there ever a time when more than one row is used? Yes, yes, yes. Well, actually, these are columns, right? You're talking about the different columns. So when we look at it, this would be 10. So just as we write, we have 10, and then we have 11, and we can count 11, 12, 13, 14, 15. And then we have 16, 17, 18, 19, and 20. So here we have 20. How do I know that that's 20? How do I know that's 20? I know that's 20 because every column, not a row, we call it columns, right? Every column is a place value, just like how we write in the abacus. Does that make sense? Just like how we write as our normal numbers. Does that make sense? Wet. So when we're looking at the number like this, 1974, we can do 1974, 1974, right? And then we can do 2025, 20, right? 0, 20, 25. So that's a year. And so when we're looking at it, it's exactly the same as how we write. Okay, good. Is the top beat always 5? Yes. I've searched up abacus and I saw some pictures that there's 2 top. Ooh, ooh. Very nice, very nice. You're absolutely right, Kat. When I look at it, that is what we call a Chinese abacus. When there's 2 beads on the top, this is a Chinese abacus. Hey, Eve. Okay. So the column you start with is intentional. It is intentional. It's usually where my dot indicator is. So if you notice, there's a one's indicator. You can have this one or you can have this one. I usually choose this one like a Pokemon. Yeah, not a problem, Eve. Yeah. No, it's a very valid question. It's a very valid question or a statement. And so it's all about attention to detail. But because I've been looking at this for a long time, of course, I'm not going to expect you to know everything about the abacus. If you did, then you wouldn't be here. So, anyways, what I'm trying to say is please comment anything that you don't understand about the abacus and I will explain it to you, not a problem. So we're going to go back to the 2 beads on top as Kat had mentioned. So on the Chinese abacus, there's 2 beads on top and it works almost very similar to the Japanese abacus. We have 1, 2, 3, 4, just like the Japanese. 1, 2, 3, 4. But notice, why am I here? Because I have my indicator here, right? I have my indicator here. When I do that, and then I have my 5. On the Chinese abacus, we're going to do a trade-in. We're going to trade this 5 to this. Now this is 5, right? On the Japanese abacus, we're just going to do 5. That will always be 5. There's no trading in on the Japanese abacus. And then we just count 6, 7, 8, 9. 6, 7, 8, 9. And then we have 10. Well, on the Chinese abacus, we have 10 because we have 5 here, we're going to trade it in. We're going to trade that in with this. So this is 10. How? Because it's 5 plus 5. But because we have 5 plus 5, we're going to trade this in to make it here. So now it looks very similar. Does that make sense, Kat? So what we just did is we just compared the Chinese abacus with the Japanese abacus. So the Chinese abacus was before the Japanese abacus. Japanese came in and said, you know what, we're going to make it more efficient, and that's what we got. You could do a lot with the Chinese abacus. You could do same amount. You could do other things with the Japanese abacus, but they work relatively the same. The word abacus just means like moving pebbles or something, and it's a Roman or a Greek word or whatever. So thank you for that, for the search. Yeah, the search is not, there's not too many searches that talk about the way I talk. So what I talk about is understanding how to read the abacus and how it relates to mainstream math. Yeah, how are we doing? Any questions? So, and I know in if you, I don't know if anybody else has done it, but I labeled it all. Fantastic. Yeah. Oh, good. Oh, good. So that was the thing, right? Like, if you look on the internet, how many people do you see do this and then show you how to label it? How do you do math with that? Well, we've been doing math with it because if we do 2 plus 5, now we have 7. If we have 7, take away 6, we have 1. So what we're doing is we're moving the beads. You are actually the ones that doing the calculations. You are the ones that are moving the beads to make sure to see if it makes sense. So this is where critical thinking happens. Does that make sense? So the first thing we're going to do is we understand how to read the abacus. Yeah? Are we okay how to read the abacus? And then after we read the abacus, oh, thank you for the like. So after we read the abacus, then we can go into adding and subtracting. Does that make sense? Bree? So when we do this, right, we have 9. When I do this, now I have 99. If I did this, what number do you think that is? Yeah, not a problem. No, thank you for your question. So that's the thing, right? Like we can do math, but it's going to only be adding, subtracting, multiplication, division. But the first thing we need to do is understand how to read the abacus. When you understand how to read the abacus, then we can go into how to add and subtract, if that makes sense. I don't want to rush anything because people get confused and they're like, it's too hard. It's actually not hard. As long as you understand how to read this. So in the comments, what number do you think this is? Thank you, Alexis. Yes, 100. Yes, 100. The reason why it's 100 because I have my ones, my tens, my hundreds. This is 100. Remember, this is the dot indicator. This dot doesn't tell me. This dot tells me where the ones is. So when we look, this is the ones. Ones, tens, hundreds, thousands, 10,000. I could choose this one if I wanted to, but then I'd shift everything over and then I wouldn't have any hundreds. So that's why I go over here so I can have hundreds. When we look, I have this number. What number do we think this is? Please put it in the chat. I think Adam left. Good night, Adam. What number do we think that is? Oh, Bree, good job. Good job, Kat. Yep, good job. Good job. So yes, it's going to be 200, 1, 2, and then tens. 5, 6, 7, 8, 9. This is 90. Thank you, Alexis. Yes. And 7, 5, 6, 7. Okay, good. So this is all making sense. So what we're going to do is we're going to understand, and then we go into understanding how to move the beads. We know how to move the beads, and I did that already. What we're going to happen is when we don't have enough. So here's the question. Here's a question when we have the 3. So we're going to add the 3. When we add the 3, and I want to add the 4, notice I don't have any more beads to add the 3. I'm sorry, add the 4. So this is where we start talking about this formula. We talk about these things that the school is teaching. So the school is teaching how to make a 5. 4 plus 1 is equal to 5. So when we look, 4 plus 1 is equal to 5. Well, why are we learning that? The reason why we're learning that is because we want to utilize this 5. So we can actually utilize this 5, and what we're going to do is we're going to, there we go. We have to isolate the 4. Why? Because we're going to add the 4. So that means we're going to isolate this 4 from this one equation, right? That's the equation that we're talking about. And we're going to get 4 equals plus the 5 minus the 1. When I plus the 5 and I take away the 1, so I was just given directions. So my final answer is 7. Does that make sense? So what are we going to do? Let's do another one. Let's do another one because it doesn't make sense to me. So we're going to add the 4. Here's the 4. When I add the 4, what are we going to do? We're going to add another 4. We don't memorize doubles. What we do, oh, good. Oh, good. So does that mean I can use this? Let me use this. So what does that mean? I don't memorize doubles. What I do memorize is the concept. I memorize the concept, right? And the concept, oh, good, you did hear it. So we have the 4. We add the 4. We want to add the 4, right? We want to plus the 5 minus the 1. We're going to plus the 5 and take away the 1. So now what this is, the concept is more universal, right? It's more not universal. The concept is more versatile, right? So we don't memorize doubles and we don't memorize doubles minus 1, doubles minus 2, whatever. We don't memorize any of that stuff. What we do memorize is the formula. Plus the 4 is equal to plus the 5 minus the 1. So there you go, Bree. What we're doing is we're adding and subtracting on the abacus. Does that make sense? So what we're going to do is we're going to do it again. We're going to do it again, right? Because we do it again, we want to add the 2. The thing about it is it's nice that the abacus has a constraint. The reason why the abacus has a constraint is so then we can start manipulating and critically think the formulas that we need to do, right? So the first question was is if I want to add the 2, is there enough beads to add the 2? Can we do it? Yes, we can. We can add the 2. However, I'm adding 2 plus 4. Is there enough beads to add the 4? No, there isn't. So what do? We now can utilize this 5. Because we can utilize the 5, we can minus the 1. See, if I add the 5, it's too much because I only want to add 4. So what we're doing is we're doing an exchange. We're doing a substitution. So when we substitute 4 with minus the 5 minus 1, I don't know how my connection is, but I'm just letting you know I'm waiting for a little bit. So now what we did is we substituted 4. Okay, good. We substituted 4 with the 5 minus the 1. So I'm going to pass the 5 and I'm going to take away the 1. So my final answer is 6. Right? So now what we're doing is we're using something that's very versatile. And again, if you look, we have 3 others to use. So when we look, there's the specific questions. So when we have this one, which is the 3, right? 4. See, what we're doing is we're utilizing the 5 now. And then after utilizing the 5, we can utilize the 10, and that will be a little bit later. But the first thing we need to do is understand the 3. When we do the 3, so I want to add 4, I want to add the 3. Well, how do I add the 3? Notice my 3, right? The concept is plus the 5 minus the 2. So I'm going to plus the 5 and take away the 2. So my final answer is 7. Notice, right, there's a number pattern, right? There's a pattern. When I add the 5, right, I minus the 2. And that will always be the case. Yeah, makes sense? Anybody have any questions? Okay. So now what are we going to do? Well, there seems to be, yeah. Okay, good. So now we understand this, not a problem. Well, if you notice, if there's a plus, we have to subtract. This is very familiar, very similar to what we just talked about, right? If I showed you, what is it? Here it is. If I did this, right, it's very similar. We have the 4 plus 1 is equal to 5. But if we do it the other way, because we want to minus the 5, we have to minus 3 minus 2 is equal to minus 5. Does that make sense? No, kind of. It kind of makes sense. I mean, do we see it all over the place? No, we don't see it. But this is just to illustrate, right? This is just to show you that when I want to 7 minus 3, to get to 7 minus 3, we have to minus the 5. So notice that when I want to minus the 3, the question goes 7, and I want to take away 3. There is not enough beads to take away the 3. There's not enough. There's not enough. So what do? I know how to take away the 5. So what's going to happen is I'm going to move this over to this side, right? I'm going to isolate this variable. I'm going to have minus 3 is equal to minus the 5 plus 2. So I'm going to minus the 5. I'm going to add the 2. So my final answer is 4. Now we know how to add. Now we know how to subtract. Make sense? Yay! I hope that's a good yay. So when we look, we want to understand. We want to be able to understand. Amazing. Oh, hey, Sign! Welcome! Right? Yeah, that's why I have. Yeah. And that was the thing, to understand how everything goes. So now we know that there is a number pattern. When I want to add the 3 and I want to add another 3, I'm going to plus the 5 minus the 2. So my final answer is 6. I can do the same thing. I can minus a 6 and minus, I'm sorry, 6 minus 3. I take away the 3 like that. You like that Sign? Aha. I thought it was funny. I forgot to do it with sunglasses. Where's my, I have to find like all my filters. There we go. I think I did it. Oop. Nope. Effect. Nope. No. Nope. Can't do it. Boo. All right. So, anyways. Nope. Can't do it. Okay. So, when we're doing this, so when we want to minus the 3, here's 6. I want to take away the 3. When I take away the 3, what am I going to do? When I take away the 3, what am I going to do? I need to minus the 5 plus the 2. I'm going to minus the 5 and I'm going to add the 2. So my final answer is 3. Now my beads are very versatile. Now I can, do things. I can do things with it, right? So then, are we okay with how to make a 5? This is why understanding how to make a 5 is critical. Yeah, are we okay? So what's the next concept? Okay, so the next concept is how to make a 10. Why are we going to do that? Well, notice, right? Oh, thank you, Alexis. Yeah. So in mainstream math, we talk about carrying on, right? Trading, borrowing, grouping and regrouping. Somebody said grouping and regrouping. I think it was Alexis that said grouping and regrouping. I don't remember, right? We talk about grouping and regrouping. But now in abacus world, we don't talk about grouping and regrouping. What we say is plus the 10 minus the 10. So when we look, I have to find my card. My card. Here is no. Card. I don't know what grade are these. Right now, oh here it is. Nope, that's not it. Right now, I'm trying to do grades preschool, kindergarten, first grade, second grade. I'm actually getting into a point where I'm getting to do working with introduction to abacus for adults, and I'm going to talk about oh here it is, and I'm going to make abacus workbooks for specific grades of 1, 2, 3, 4, and 5. So if that makes sense, but typically in the abacus world, we start with the kids at ages 5, 6, and 7. um, Kids that are 11, 12, 13, we can teach them. That's not a problem. It just depends on if they're super busy, if they're open to learning something new. And so it all depends on every child. And it also depends on the parents. Like, are they willing to invest in the time? because it's just like anything new, right? There's going to be some static, there's going to be some friction on learning something new, but once you get to the idea of like how to move these things around, then it'll be a lot easier. And I think it's beneficial to have the kids to understand how to see the numbers, because learning that this is 8, I think, is more beneficial than seeing this number is 8, or even seeing the pictures, right? So I appreciate the thank you, Sun Tan. Thank you, San, for the question. So when I look at it, right, we in the mainstream world, right, we're making pictures how to make 8. 1 2 3 4 5 6 7 8. And I think it's very different when you see it on the abacus, which is really interesting. It's so true. When a child's able to see the beads and the numbers as a total, as a game changer. Yeah, and I notice, like, even when I have like even when I show you a picture of the abacus, it still doesn't translate because it's not a physical thing. And I think what we do is we try to push the kids to be too to do mental math too quickly. And I think they just need to do this. But then the problem is when we go to the next extreme, we go to the extreme like, well, let's count these. I'm like, the brain can only see maybe 5 things at a time, right? So this is where you count like six. 1 2 3 4 5 6, but you don't see it six like this, right? Whereas here we see six, we know five, and we know six. We know we have to mentally remember that this is five. So when we see this is six, we actually have to count it. We either break it up into half like this, or we have to like break it up into twos like this or something, right? We have to do something with this. And I think it goes like mainstream math becomes a little bit too much, like, what do you call it, what do you call it, like too granular. That's what it is, too granular. And I think they go from one extreme to the other extreme. And I don't know, I don't think that's appropriate. Here was a thing that I found, and I was like really annoyed. I was really annoyed. I saw this and I was like, oh my god, why are we doing this? And I mean, it makes sense, but you got to count that. You got to count that. That's a lot to count. So let's see it on the abacus. This is 182. I have my abacus. I have 182. Easy. That's a lot of bricks. I'm just saying. Now I'm on a rant. I get a little salty when I talk about mainstream math and stuff. So, and the reason why is because I truly believe that abacus is a forgotten tool. It's a forgotten tool that people don't right. I believe that abacus is a forgotten tool that, I mean, it's great. So that's why, you know what, that's why I'm going to flood the market with all of my abacus driven worksheets. But yeah, it's the interesting thing. Okay, we're back to here. So we're going to be doing how to make a 10. We're going to make a 10. When we make a 10, what are we doing? Why are we going to make a 10? We're going to make a 10 because we need to understand how to carry over, right? Oh, it's amazing. Absolutely love it. Oh, thank you. Thank you, sign. Thank you. I appreciate that. Oh, yeah, thank you. And I have the my my minus fives. It's actually in it's pending right now. So it's pending publishing, and it will be available in a few days actually, which is I'm really excited. Okay, so so the next thing we're going to do is we're going to um San, did that make sense? Um, that was a fantastic question. I'm so happy you asked, because it does. Because some people just, because it doesn't make sense. A lot of people are like, "Why are we doing this?" It's like, well, to understand, right? And I've been teaching abacus for 20 plus years, um, and I noticed that there's a benefit to it. I see the benefits, and it's harder to ask kids who are young, what is the benefit of the abacus? They're not going to see it, but because I came from memorizing stuff, because I came from memorizing math and then going into abacus, I see that there's more benefit in doing it through the abacus method. And then the funny thing is new math follows abacus. which is really interesting. But the difference is, new math uses paper and pen still, whereas the abacus, it's there for you. So we can show, well, depending on how far we get, it will see itself. You can see through multiplication. So what is the last two? Oh, that's a good question, Kat. It's the decimals. So when we look, we have $1.25. So when I look, one oh no 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 no, I could do $1.25. That's what those are doing, right? Just like when we count money, we have two digits. Yep. So, or we could do $1.50. $1.50 would look like that. Does that make sense? So yeah, it'd be for the decimals. And if you notice, that's what the dot is. The dot doesn't take this dot take a place value. It sits between the ones and the tenths. So then all abacus has columns. Um the abacus that I have all have columns. There are some abacus that are not column. They have rows, right? And that's the what? That's the let's see. That's a reckon rec. So a reckon rec is a rows reckon reckon rec reckon rec. Yeah. So we have this. No. This? No. What's it called? A reckon rec abacus. Sorry, I'm trying to find it for you. Okay. So no. Continue. No, I don't want that. Okay. So there's these. So if you notice, this is a reckon rec. It has it, but it goes what across. It goes more of a row, whereas this one is a like a Russian one, but this is now considered like a preschool abacus, and this is 10 beats across, and then this one is the same. It's a 10 beats across. The different colors, there's five colors that are red, and then there's five beats that are white. It's just they're just broken up that way. Yeah, this is called a Soroban abacus. That is correct. So this is correct. This is called a Soroban abacus, like the ones with the decimals. Yeah. So the ones with the decimals. So we could do this one is my ones. We could do it like this, right? So we have our ones or tens, and then decimals: tenths, hundreds, thousandths, millions, and 10 billion. I don't know. Right. So yeah, that would be the decimals, but that depends on where your ones indicator is. If that makes sense, Kat. So when we look, it just depends on what indicator it is. You could use the 13 column one. I do have this one as well as in my TikTok shop. This one is 13 columns and size matters. I love that joke. I love that joke. The reason why is because why? Because it all depends on the digits. And if you notice, I have a dot over here, so now I can have my ones over here. So my ones, thousands, millions, billions, trillions. I got jokes. I got jokes. So when we look, right? So if you notice, every grouping is a comma when we write in the American Eurocentric, not even Eurocentric. It's more American, right? Because Americans do commas and the Europeans do dots, right? They do, they're not decimals, they're dot separators. But in America, in North America, I don't know in Mexico, but in North America, America and United States and Canada, I know we do commas. So we have ones, thousands, millions, billions, and trillions. Yeah. Does that make sense, Kat? But yeah, that's a good question. So these are columns, and yeah. And then the one, so if you wanted to, you could start over here and then you have all of this to be your decimal. Or you can start in the middle, right? And then you have these to be your decimals, and then this will be your whole numbers. Yeah. Yeah? Okay. So what are we doing? We are talking about how to make a 10. Now the reason why we're talking about how to make a 10 is because what if we don't have enough? So when we do 7, we add 7. We're going to add 7 to the abacus. We add 7 to the abacus. When we add 7 to the abacus and we want to add the 8, notice I don't have enough beats to add the 8. Because I don't have any more beads to add. Hey, Sincere, welcome back. Because we don't have enough beads to add the 8, what do? We know this formula. We know that to make a 10, how to make a 10 is 8 plus 2 is equal to 10. So when we look, we're going to isolate this variable. What? That's the same thing. It is. We're taking a concept and we're practicing the same concept but with different numbers. So when we have the 8, we're going to do 8 is equal to plus the 10 minus the 2. Thank you. Thank you for the wave. So when we do is we're going to plus the 10. Plus the 10 means what? Remember when I added the 1 and I made a 10? That's a 10. 0, 1 is a 10. 0, 1. So when I have 7 and I need to add the 10, I'm going to do 0, 1. I'm going to add the 1 here and then need to take away the 2. When I take away the 2, my final answer is 15. I add the 1 and the 5. Does that make sense? How are we doing? We all right? What's going on? Thank you, everybody, for joining. My name is Lynette. I've been teaching abacus for about 20 years, and I'm going to go to sleep. Good night. Oh, good night, Kat. I'll try to next time. Oh, yeah, not for sure. Can you do one more? Yeah, of course. Of course, Alexis. Of course. Not a problem because I have plenty of more questions. Thank you. I appreciate your questions because I don't want to talk to just the void. It's always nice to have a conversation, but thank you. I appreciate that. Hello, Grace. Welcome. So what we're going to do is we're going to do one more. We do 4. When we add the 4, I want to add the 8. When I add the 8, what are we going to do? We're going to plus the 10. We don't have enough. We do not have enough. So what do? We have to add the 8. We're going to plus the 10 minus the 2. Plus the 10 means what? 0, 1. We're going to add the 1. And then we're going to take away the 2. We take away the 2. My final answer is 12. Oh, thank you, Sign. Yes, you're absolutely right. 10 minus the 10 plus the 2. We can rewrite it. We can do 8 is equal to minus the 2 plus the 10. This is what we call commutative property. I just, there's all these terminologies that makes me mad. So this is what it is. So if you notice, we can have plus the 10 minus the 2 or minus the 2 plus the 10. This is the same. It's not really because the definition says in addition state, what changes is the order of the numbers being added and not the sum changes, which is not really true in abacus, right? And I'll show you in a little bit what that means. But we can write it in abacus world, we can write it either way. It doesn't matter. But it's nice to be able to be flexible because it all depends on um, what happens when there's a two-step equation, and depending on the time we can get into two-step equations. So are we okay, Alexis? Do you want to do? We can do one more. Let's do another one. So when we do 9, we have 9. When we add the 9, I have 9. I want to add the 8. When I add the 8, I don't have enough beats to add the 8. So again, I'm going to minus the 2 plus the 10. I'm going to minus the 2. I'm going to plus the 10. Plus the 10 means 0, 1. I add the 1 over here. So my final answer is 17. Hey, Purple, welcome back. It's been a bit. So my final answer is 17. 17. Does that make sense, Alexis? So what we just did is we're understanding the two fundamental formulas. The two fundamental formulas. And again, okay, good. Oh, good. I'm so happy. So when we look, we have all of these to remember, but it's easy to remember because it has a lot to do how to make a 10. When we look, if I want to add the 9, we have to know that the partner is 1. And then if we have 8, the partner is 2. 7, the partner is 3. 6, the partner is 4. 5, the partner is 5, and then so forth. But notice we have 4, 3, 2, 1. What? Isn't it plus the 5? No, this one is plus the 10. Now, why are we knowing this? Well, if you notice, there is a difference if we want to add the 5 or if we want to add the 10. When we add the 5 and when we add the 10. Now, when do we do this? It depends if we have enough beads. So if I have 4, I want to add another 4. Do I have enough? Do I want to add the 10? No. Now it's too much. What I need to do is I need to add the 5. So plus the 4 is what? Plus the 5 minus the 1. So then I have 8 and I want to add another 4. Can I do it again? Can I add a 5? No, I can't add the 5. So then what do? I got to go over here and I do plus the 10 minus the 6. So I plus the 10 and I take away the 6. So my final answer is 12. How'd that go? We're all right? Okay, good. So it makes sense. So it goes in a framework. But see, that's the secret. You know how to do this. You will know how to do this at scale. So it doesn't matter what the number is, you can do anything. You can do any of them. So again, because we have a plus, right, we can do a minus. So if I plus the 10, I'm sorry, plus the 9 and minus the 9, I can minus the 10, minus the 10 and minus the 1. So it depends on the amount of beads on the abacus. It does depend. It depends also, yes, it does depend on the beads on the abacus, and that's how you know what to use. That's why abacus adds critical thinking, because when you see it, can you do it? That's always the question. Can you do it? If not, how else can you do it? How else can you answer the question? But yeah, it's exactly what it is. And that's why it's nice to see it on the abacus. Like I know 19 and I want to add another 8. I know I have to plus the 10, take away the 2, right? Which is different if I did this. If I just showed you 19 plus 8, how do we know what this is? We don't. Logically, these are abstract numbers. We have to memorize what 18 is, and we have to memorize what 8 is. And who in their head knows what 19 looks like? I don't know what 19 looks like. I know what 19 looks like on the abacus. So when I look at it, I go 1 and 9. And then on the abacus, it helps me. Oh, I need to add the 8. I don't have any more beads to add the 8. So what do? All I need to do is plus the 10 minus the 2, and I'm done. And then I look my abacus again and be like, oh, my answer is 27, right? So the difference between this and then this is that we have to think abstract. What do we do here? Well, in school, they do number line, right? 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we have 19, 20, 21, 22, and then they have to count 1, 2, 3, 4, 5, 6, 7, 8. That doesn't make sense to me. Why? Because it's still a picture, right? Even though I have these abacus as a picture, it still doesn't translate it, which is very interesting. Like to me, as a person I'm very visual, but because I have it in my hand, because I can physically touch 19 or 18, 19, right? Because I can physically touch it and see, I have a better understanding what 19 looks like. Does that make sense? Yeah, I'm trying to not go off the rail on this, but I do notice that we're trying to do many different ways, like this number bond. So you break up this 19 into two. There's a 10 and then 9. And this is new math, which is the same as abacus. Okay, good. Okay. How are we doing? Bonjour. Hey, Bible, bonjour. It's almost midnight in US. It is. It is. I didn't know you speak French. I don't speak very much French. I only know very little. The reason why is because I actually grew up in Canada. I grew up in Toronto and then I moved to America. So, yes, we're going to start talking about two step equations now. So, what is a two step equation? we're okay with how to make a 10. When we make a 10, if anybody's interested, this is available on my shop, my TikTok shop, or if you want to, I do have it here. My name is Lynette. I've been teaching abacus for about 20 plus years, and I am very happy that you guys are all here voluntarily learning math. So, what we're going to do is we're going to do the two-step equation. What does that mean, two-step equation? I know your times now. I learn languages. It's my. Oh, hey! What other languages do you know, Bible? I only know English because I'm a simpleton. I know a little bit of Chinese, but I don't think I know enough to save my life. I know a little bit about Spanish, but that's only to order some food like a burrito with like meat. And I know very little anything else. So I'm very impressed. I wish I could. I don't. I don't. Uh, I'm hoping my kids will learn Mandarin. Um, But anyways, so what are we doing? We are doing this number. We're going to do this number. So the question is, well, isn't it the same to do 8 plus 5 and 5 plus 8? And it's like, no, it's not. Why? Because what we're doing is we're figuring out oh, excuse me, we're figuring out this add-in. That's what's going to stop us. Besides the 9, 12 South African languages, I speak French, Spanish, and Portuguese. Oh, see? That's impressive. That's impressive. I'm not. I don't. I'm not that smart. What is the difference between the two? Oh, hey. So the difference between the two is the add in. So the add in. It's the second add in that's the difference. And I'll show you. When we look at it, we add the 8. When we add the 8 and we add the 5. Now we know how to add the 5, right? We know how to add the 5. How do we add the 5? We know to add the 5 is plus the 5 is equal to plus the 10 minus 5. So I'm going to minus the 5 and plus the 10. So my final answer is 13. That's fine. But notice we're not going to focus on the result. What we're going to focus on is the add-in. So when we look at this add-in, we need to see what's going on. We have 5. We add the 5. Now my question is to add the 8. Is there enough to add the 8? No, there is not enough to add the 8. So what are we going to do? Plus the 8. We know how to plus the 8. Plus the 8 is equal to plus the 10 minus the 2. So I'm going to plus the 10, 0, 1, 0, 1. I'm going to add the 1 here. I'm going to add the 1 here. Now I have to take away the 2. Notice I don't have any more beats to take away the 2. Do you remember what we do? What do we do to take away the 2? What happens? This is now what we call a two-step equation. This is going to get, because we don't have enough, we cannot do Bob the Builder. We don't have enough to minus the 2. What is another way to minus the 2? Minus the 2 is equal to what? What's another way to minus the 2? Yes, thank you. We want to do minus the 5 plus the 3. 5 up, 3 up. That's a good one. 5 up, 3 up. Yep. And so if you look, my answer is 13. My final answer is 13. But notice, hey, Scuttles, notice, right? The answer is the same, but the problem is how you get there is different. So I'm hoping everybody wants to be happy, but everybody's happiness is different. It's all about the journey. So when we look at the add-in is always going to be the edit the advocate the add-in will always be the determining factor of what you're going to do. Does that make sense? So, Scuttles, let me know if you have any questions. If you need a review, we can review, not a problem. If you don't understand, it's okay too. We could do it. We could do it. Thank you so much for the right? But that's the strange thing, right? The strange thing is in mainstream math, we focus on the result when we shouldn't. What we should focus on is this add-in. The add-ins is what makes and breaks our journey. I'm learning a lot. Oh, hey, Rizzo. Good. Great. I didn't know you were here. I apologize. I didn't understand. I didn't know you were here. But let me know if you have any questions. So when we look at it, right? Again, we'll do it. We'll do more two-step equations. I don't know if Alexis is still here or did she go to sleep? Because I know it's pretty late, and yeah. Okay. So how are we doing? Any questions? You're still here. Okay, good. So Alexis, did the two-step equation make sense to you? We're gonna do some more. But I want to know if that was okay. And then understanding that the understanding the add-ins. The add-ins is the key to everything. How we do it and why we do it. Okay, so let's do another one. Okay, we do another one. Again, we don't memorize doubles, right? So I'm going to show you a double. 7 plus 7. 7 plus 7. 7 plus 7. We know how to add a 7. That's how we do 7, right? 5, 6, 7. Now what do we do is we're going to add another 7. Can we add another 7? Oh, I have to go Bible. Oh, Bible. Okay, yeah. Go to class. I will see you in my next live. Thank you again for dropping by, Bible, and I will see you soon. Bye. Have a good day. Okay, so then 7. When we have 7, what do we do? What is the formula for 7? Do we remember? Do we know how to make a 7? How do we um how do we add a 7? When we add the 7, we know this is what we're going to do. 7 plus 3 is equal to 10. We're going to isolate our variable. Oh, thank you. 3 and 4. Ha ha ha. No. No, what we're going to do is we're going to understand how to make a 10 with a 7. So we need to find the partner for 7 when we try to make a 10. The reason why we want to make a 10 is because we want to use this other column. This column is our tens. When we look, we want to isolate this variable. So 7 equals plus the 10. Adding the 10, this equation is no longer balanced. To balance the equation, we're going to have to minus the 3. Does that make sense? Yes. So when we add the 7, we're going to plus the 10 minus the 3. Plus the 10 minus 3. Is there enough? We're going to plus the 10. Yes. Now what we're going to do is we're going to take away the 3. There is not enough to take away the 3. Do you see there's only 1, 2 beads? Alexis, are you still here? So what do we do when we minus the 3? Do you know how to take away the 3? How do we take away the 3? Because I don't have any more beads. Ah, Rizzo, thank you so much for the heart me. Do we remember the equation to? Do you remember the equation to minus the 3? Yes, Mike. Yes. It's minus the 3 equals minus the 5 plus the 2, right? So we're going to take away the 5 and we're going to add the 2. So my final answer is 14. Thank you, Michael. Thank you, Mike. So what did we just do? We did a two-step equation. We had to substitute the 3. We had to substitute the 3 with this. So see, I told you. No, because you said and 4. That's not right. How'd you get the 4? Okay. Alexis, is you okay? I'm not quite sure how to help you with that. I did it in my head the way you said. Oh, I see. So, okay, good. Yeah, so this is what we call a two-step equation. When you do two-step equation, it's using the tens and the fives. And what we're doing is we are Tetrising our information. We are trying to fit it like a Tetris. We have each block has a specific thing because the 4 goes up. The 4 does not go up, Rizzo. The 2 goes up because I have this. This is what I have is 7 plus 7 plus another 7. So what I did was I minus the 5 and added the 2. That's what I did. Ah, so you're saying at the end, this is the 4 up. Mm, mm, mm. I could see that. I could see that. But I wouldn't think of it that way. I wouldn't think of it that way. Why? Because we have directions. When we have minus the 5 plus the 2, that's what it'd be. It'd be minus the 5 plus the 2. So yeah, that would be a little bit. That'd be a little bit of a stretch, but I don't think of it that way. I think of the formulas. Because the thing is that you have to memorize the formulas. So I see that. I kind of see that. Um, but it would get more confusing when the numbers get bigger, and I think that's what I kind of be careful with, because when the numbers get bigger it can get confusing really quick. And also don't forget, like, one, it'll be more numbers, and two, it can be multiple add-ins. So I'd be careful with saying 4 up. Yeah, yeah, that's what it'd be because of this. And when the number starts to get bigger it will get complicated quickly. All right. So that's it. That's what I got. Any- Anybody have any questions? We can do more, but okay. How are we doing? All right. So what are we doing? Oh, more. Oh, okay, not a problem. Getting the hang of it. Oh, fantastic. Fantastic. All right. So we can do, let's see. Okay. We can do this one, which is 8 plus 6. We've done this before. No, we haven't. We've done 8 plus 5, but now if you look, 8 plus 6 is different. We want to add the 8. When we add the 8, what are we going to do? We're going to add the 6. What is the formula to add the 6? Do you know how to add the 6? What's the formula to add the 6? Plus the 6 is equal to what? Plus the 10 minus the 4. So plus the 10, 0, 1. Plus the 10, 0, 1. So then I'm going to add the 1 here. Now I need to minus the 4. Notice when I minus the 4, what am I going to do? I don't have enough. Can we do it? No, we can't. So what are we going to do? Minus the 4 is what? Minus the 4. Yes, thank you, Sincere. It is. Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. So my final answer is 14. Oh, that's convenient. Excuse me. Okay, so let's do another one. We could do 27 plus 6. 27. So I'm going to add the 2 and then the 7. I'm going to plus the 6. To add the 6, what do I do? Plus 6 is equal to plus 10 minus 4. So then what? We're going to plus the 10. Excuse me. We're going to take away the 4. Again, cannot take away the 4. Now what we're doing is we're going to minus the 4. Minus the 4. Can we take away the 5? Yes, we can, right? Minus the 5 plus the 1. So my final answer is 37. Yes, that was easy. right? 30, is that right? 37? Wow, that's not right. We have 7. Oh, minus the 5 plus the 1. 33. There we go. 33. That's our answer. 33. Why? Because it's 7 and then plus the 10 minus the 6. Minus the 6 is minus the 5 plus the 1. 33. Yeah. Cool? Yeah. Yeah. And so that was the thing, like, because sometimes I forget it's getting late. I'm starting to see that I'm going to start making mistakes. It is getting late. Okay, cool. That's great. So what we're doing is we're understanding how to do a double two-step equation. Two-step equation is very common in algebra, and so understanding this makes understanding how to do this, and it becomes like easy. Then you have more brain power to do more complex math. So that's the reason why we want to like have a solid foundation on arithmetic. But yeah, whew, I do think I'm about done. I'm tired. I'm tired because when I start making mistakes on something like this, then I know my brain's not braining. So I appreciate everybody joining and everybody showing up. I don't know if Rizzo is still here. Thank you, Rizzo, for commenting. All right. If anybody has any questions, if not, I am going to sign off. It's been a little bit. But I do appreciate everybody joining and showing up in the middle of the night learning math. You guys are all nuts. You guys are so awesome. That's fantastic. I do appreciate everybody joining. It's been fun. I'll be back. Oh, good, Alexis. I hope so too. It's always it's always a little bit, right? Like to wait for all the people to come back and get the regulars. And then it's great to have like new people. But it's always like the spammers that I'm always scared of. Not scared, but like I don't know. I have to always be careful. I have to be always be on my toes. So it is what it is, but it's still fun to go live and I do enjoy it. Okay. So if nobody else has any more questions, I do appreciate everybody spending the time with me and learning how to read the abacus. And if you want, I do sell the abacus on my TikTok shop. I do also have books if you guys want. I have books available here. I also have it on my TikTok shop. I'm still building out my shop, and we're going to do some printables, not printables, laminated stuff. So, like, there's these, I'm going to be selling this laminated. Utilizing the 10 bead. So, smoke. Hey, smoking. Hey, I don't know if you remember. Yes, I remember you. Smoking, because I remember smoking. But I do apologize. I am going to sign off. I am a little bit tired, and it's been a little bit. But was there any specific questions that I can answer for you, smoking? Because I remember you were smoking and you were happy. Didn't ask what you were smoking. All right. Yes. So I love you, Teach. Thank you. I appreciate it. Yeah. It's just I was just saying that, sometimes people are spammers and I'd be like, who are you? So I don't mean to be harmed. I don't you know what I mean? I don't mean to be rude, but sometimes I have to like be on my toes. Okay. So if there's no other questions, I am gonna sign off and I appreciate everybody being here. I will see you the next time, smoking. Okay. Everybody have a good night, and I will see you guys all in my next live. Thank you so much for the hand heart. Oh, Enrique, go back to sleep. All right, all right. I gotta, yeah. So I don't know if it's the same Enrique. Okay. Have a good night, everybody, and I will see you guys all in my next live. Bye. Thank you so much for liking the live. 12 people. Oof. Oh, excuse